If statements are very useful in programming. Let's take a look at how they work in Python. If we do something like x equals 3, and then we say something like if x equal 3, colon, and then write something like print x is 3, and we run the program, we see that indeed the statement prints out x is 3. If x was something else and we run it, then nothing happens. Okay, so let's break this down a little bit. First of all, x is being assigned a certain value, 3 or 4 or whatever. And then on the next line, we need to check what x actually is. And to do that, we use this double equals sign. So the difference between these is that a single equal sign is used as assignment. The right-hand side is evaluated. In this case, there's nothing really to evaluate. And then it's substituted into the left-hand side. On line 3 here, there's a difference. X is some value, in this case 3. There's some value on the right-hand side. And the equal sign checks if the left-hand side is equal to the right-hand side. If it is, it returns a value of true. If it's not, it returns a value of false. The way an if statement works is that if you get a true value out of whatever you're trying to evaluate here, then the next part indented in your if statement will execute. So in this case, print x equals 3. Of course, this is pretty boring. We could maybe do something a little more interesting by doing something like if x is not equal to 3, then print x is not 3. So it still works if x is equal to 3. But here with this, this is the reverse of the equals. This is checking if they're not equal. So if we change x to, for instance, 4 and run it, we get x is not 3. You could imagine, though, that this kind of situation would occur a lot. You're checking if something is one thing or another thing. And in that case, you might even be checking if there are many different, through many different cases. So in that case, it's a little more convenient to use an else statement. So if x is 3, it's going to do the first thing. If x is not 3, it's going to do the second thing. So we run it. In this case, x was 4, so we get the second statement printing out. And here, if x is 3, we get the first statement printing out. Okay, so that's a pretty simple example, but just a basic idea of how these conditionals can work. Let's try something maybe a little bit more interesting. Let's check if a number is odd or even. And so to do that, we can use the is instance thing. So excuse me, we can use a modular arithmetic. The way modular arithmetic works, you might see this in mathematics written something like, say 7, and then often in parentheses, mod 5 maybe. So 7 mod 5 is equal to or congruent to 2. The idea is that you take 7, you divide it by 5, and you look at the remainder. In this case, the remainder is 2. In Python, we don't write mod 5. Instead, we write 7. So 7 mod 5 would be written 7% symbol 5, like this. So 7% symbol 5, if we enter that down here, 7% 5, indeed we get 2. And this will work for negative numbers too, -3 percent 5, right? We still get the same answer we would get if we took -3 mod 5. Great. So the nice thing about using a mod function in this context is that it gives us a quick way to check if a number is odd or even. So for instance, since x is even, I can check, since x is 3, it's odd, we can check x mod 2, right? That 3 mod 2 gives us 1. A remainder 1 upon division by 2 means that you are an odd number. So so we can say something like this: if x mod 2 equal 0, print x is even, and I need quotes. Else, you notice that this won't work if I just write it like this. For some reason, Thani has not immediately taken the indentation to the left, so I need to do that manually. But then we can print x is odd. Again, in new quotes. Okay, so if we try that, x is currently 3. So if we run it, x is odd. If I put in x is 2, I get x is even. Great, and maybe we try it with something else like 77, and we get x is odd. Okay, seems to be working all right. But notice we did something like x is 77.1, we get x is odd. And normally 77.1 we wouldn't think about as an odd or even number. It's normally reserved for, it's normally a property of integers. So we need some way of checking if users maybe entered in some other number. And to do that, we can nest the if statements. This is fairly straightforward, similar to nesting loops. Maybe we'll do something like if, and then we want to check if, we want some statement here that checks if if x is actually an integer or not. And one way to do that is to use the function isInstance x comma int for integer. So this checks if x is an integer, and then the next statements will execute. But this isn't quite right because we need to follow the proper indenting. What this currently will do is check if x is an integer, and then if it's an integer, nothing will happen. It'll execute the next line, and then it will move on to where nothing happens, and then it will just move on, forgetting about this line and executing the next few lines. So what we need to do is indent these properly so that they're below the previous if statement. And we could do that by putting a bunch of spaces here, but that's kind of time consuming. So most IDEs will have a nice way to do this. In Thonny, you can just hit tab to move indentations over. I can do that a few times. If I want to indent, I can hit Shift Tab, and it will bring it back. So first, I can bring it all the way back. Okay, but I want it indented there. So now this if statement is checked. We check if x is an integer. If it is an integer, then we'll go on to do our odd or even check. If it's not, maybe we'll do something like else. Print, please enter an integer. Of course, we could have more sophisticated error checking than this, but this is just a quick way to demonstrate the idea. So sure enough, if we write x is 77.1, we get please enter an integer. Otherwise, we get something. Otherwise, if we enter, say, x is 77, it runs as normal. So first, it's x is an integer, and it goes into this even odd check. If x is 76, and we get x is even. Great. What if x is a string? What if your user enters something like ABC? Then this check, at least at this stage, brings it down to, right, it's not an integer, it's a string. And so something else has happened. And then it says, hey, please enter an integer. So that's just a quick little way to check if these things are behaving as you want them to behave. If statements are pretty common, but there's one last keyword here that we'll take a look at, and that's the else if. So in Python, else if is abbreviated to elif, just I guess for less typing. And this can be useful sometimes if you want to check a whole bunch of conditions in a row. So for instance, let's do something like, let's use like a weather advisor. And so we'll do something like give the user some output based off a temperature. And let's let it be a temperature that they entered. So we can do something like temp is equal to, and then we want input. So this is a user input, enter the temperature. And maybe they'll enter it in Fahrenheit. Sorry, fans of Celsius. We'll just try this for now. So do something like this. So the user will enter something, and then it will be stored in temp. So if we print temp and run the program, print temp, run the program, let's say we enter 75 degrees, and it spits back 75 degrees as expected. There's a little bit of a problem here, though. If I want to do something like do some operation on the temperature, right? So maybe I do temp +1, and I run it, enter temperature 75 degrees, but now I get an error because I was trying to do some arithmetic on temp, and temp, even though it looks like a number, we've entered it, the way it comes in through the input is as a string. So it just looks like, to Python, this looks like just the characters 7 and 5. It doesn't have any understanding that this should be thought about as a number. There's a quick way to get around that. We can enter something like int if we want to convert the string into an integer. But since temperature often doesn't have to come in an integer, we can use float. And float will convert our string into an integer, into a floating point number. So if we run something like this, it asks us to enter temperature 75, and we're asking to print temp +1. Okay, so now we can do, now temp is acting like an integer. Okay, with that out of the way, let's do something like this. If the temperature is larger than or equal to, so that's greater than equal to, that's how it's done in Python, say 90 degrees, we could print something like, say, too hot. All right. If I need a quote there, but maybe if the temperature is, maybe I want a range of temperatures. So then I can say, I mean, I could have something like, if the temperature was bigger than 90, print something. If the temperature was between 70 degrees and 90 degrees, print something else. If the temperature, it gets a little bit tedious. So instead, I'll use an else if temp is, let's say, greater than or equal to 70, something like that. Then print, perfect temperature. All right, and then we can have another one, else if or elif, and let's say, we'll do that if the temperature is bigger than or equal to 50. We can say something like, right, a little chilly. Great. And then maybe we want to just do for something for any lower temperatures. So we'll end with an else. So any other statements that, any other temperatures that the user enters here, we'll say print, burr, something like that. Okay. So if we save this and run, enter temperature. So if we enter 75, it says, hey, perfect temperature. If we do that again, enter a temperature of, let's say, -44, it's going to say burr. Okay, temperature between, let's do something very hot, a very, very high temperature. And if we do something, like 65.3 degrees, then we get a little chilly. And notice that we're able to enter in decimal numbers and things like that. If you can experiment, if instead of float you use int, you might have a little bit of a different outcome. Okay, so that's just a quick introduction to if statements, and thank you for your attention.